This should be the this week is week 13. This is tutorial 11 for week 13 and 14. So for this week, we will cover the surface integral of scalar field, only 2 questions. Surface integral of vector field, only 2 questions. And then left the Gauss theorem and the Stokes theorem at the last week. Next week. So first of all, we look at the question 1 of surface integral of scalar field. Evaluate the surface integral. The space integral here, y plus z d capital S across the surface S, where S is a part of the cone z equal to square root x squared plus y squared.
Dokter tak on mic ke?
Oh. Oh, yes. Mic is not on. Then I repeat again. Okay, we'll start the tutorial 11, week 13 to 14. Okay, this week is week 13. We are going to cover the surface integral of scalar field and vector field. Okay, first of all, look at the question 1. Okay, evaluate the surface integral. Surface integral y plus z ds. Memory problem because I'm running the MATLAB and Python together. Lacking of the RAM. Okay, where the surface S is part of the cone, where the cone is z equal to the square root x squared plus y squared. Okay, equation 2. That lies between the plane z equal to 1 and z equal to 3. So this is a surface integral of scalar field. Okay, go to the solution. The surface S is a cone. Okay, cone z equal to square root x squared plus y squared, where this is the upper cone. This is x. This is y, vertical is your z-axis. This is the upper cone. Okay, that line between, you want the plane z equal to 1 and z equal to 3. Let's say, this is 3, and from z equal to 1 up to z equal to 3. And then, the surface integral y plus z d capital S across the surface S. Z is, you replace the z by the square root x squared plus y squared. ds is actually 1 unit of the surface area of the is actually given by this is a zx squared plus zy squared plus 1 dA along across the region R, where the z is given here. So you have z equal to the square root x squared plus y squared. From here you find zx is your del del z, your del del x, x squared plus y squared power half. So you have half, and then x squared plus y squared. Okay, for differentiation, power will be minus 1. So half minus 1 will be minus half. And then you del del x squared plus y squared. That's why you get, this is actually get 2x divided by 2. And then the x squared plus y squared power negative half is actually, you bring down to the denominator, become square root x squared plus y squared. Simplify it, you will get x over square root x squared plus y squared. Similarly, if you do for zy, the difference is only del del x will change to del del y. That's why the zy you have y over square root x squared plus y squared. Okay, in the surface integral of scalar field, okay, ds change to similar to the formula that you find the surface area using double integral, which is the z squared ds is actually the square root zx squared plus zy squared plus 1 dA. Then find the zx, zy, you plug into the formula. After you change the ds, it becomes this square root dA across the region R. That's why you need to project the this one. The cone is actually from 1 to 3. 1 to 3. So you need to project it on your xy plane. Then you will get the projection of a region R. So this one, you project it on your xy plane, you will get a the region R is a donut region where your R is actually bounded from 1 up to 3. Why 1 up to 3? Because when z is bounded by the plane z equal to 1. When z equal to 1, write 1 to 3. You have the z equal square root x squared plus y squared. When z equal to 1, 1 equal to square root x squared plus y squared. So you square it, you have 1 equal to x squared plus y squared. That's why r equal to 1. Similarly, when you plug in z equal to 3, 3 equal to square root x squared plus y squared. That's why you square both hand side, x squared plus y squared equal to 3 squared. So r squared equal to 3 squared, r equal to 3. That's why the projection R is actually, you have the donut area bounded by R equal to 1 up to R equal to 3. Because your surface is actually cone but bounded by from Z equal to 1 up to Z equal to 3. Once you change later, this surface integral of scalar field, ds you change it to square root zx squared plus zy squared plus 1 dA over region R. Region R is circular region where you apply the polar coordinate, and the R is from 1 to 3. Okay, and it's involve all four quadrants. That's why theta from 0 to 2 pi. Okay, and then dA will change it to r dr theta. Okay, and y will be changed to r sin theta. Y is r sin theta. Okay, and then x squared plus y squared is r squared. Okay, zx squared. Okay, you squared it. This is zx. Zx squared you have x squared over x squared plus y squared. Okay, zy squared you have y squared over x squared plus y squared. The y squared over x squared plus y squared, and then we have plus 1. Okay, dA become r dr d theta. Okay, and then you simplify this one first. 0 to 2 pi, 1 to 3. So r sin theta, square root r squared, we have r. Okay, outside here we have r. Okay, simplify this square root, you will have x squared plus y squared. Okay, you combine these two. dr d theta. Okay, so expand here, you have r squared r. The factor out r outside sin theta plus 1. This is r squared. I factor out r. Okay, this one you have cancel it. You have 1. So 1 plus 1 you have exactly set to dr d theta. This is 2. Set dr d theta. Okay. Set 2 is constant, factor out. Okay, and then after factor out set 2, integrate r squared respect to r, where sin theta plus 1 is constant. Okay, but don't factor out because later on we are going to integrate respect to theta. So you have factor out set 2, so 0 to 2 pi, integrate r squared. Okay, we have r cubed. Okay, divide by 3, okay, is constant and factor outside. So r from 1 to 3. Sin theta plus 1. Okay. I put it next just near to d theta because we are going to integrate it with respect to theta later on. Okay, now plug in the limit for r. 2 over 3 is 0 to 2 pi. So 3 cubed 27 minus 1, and then integrate sin theta plus 1 d theta. So 27 minus 1 is 28, 26. So you have the 26 set 2 over 3, integrate 0 to 2 pi sin theta plus 1 d theta. Instead we have this one, 26, it's set 2 over 3, integrate sin is negative cos theta, integrate 1 is theta. Substitute theta from 0 to 2 pi. cos 2 pi is cos 2 pi plus 2 pi minus cos 0 plus 0. Cos 2 pi is positive 1, so negative 1. 2 pi. Cos 0 is 1, so minus 1. So this one, negative 1, negative minus 1, so positive 1 answer. So lastly, you have the answer. This is 2 pi. 2 times 26 is 52. 32 pi over 3. So 52 pi 32 over 3. So basically, the surface integral will comprise a ds as a surface area in double integral. And then because after that dA is double integral is in terms of your x and y, that's why z, you have to substitute back z is a function of your x and y. In this case, the z is a square root x squared plus y squared. Later on, this part basically likes your double integral. Any question for question 1 here?
Betul.
Yes.
Yang sin theta tu dapat dalam mana?
Y. Y in polar coordinate is r sin theta. And then x squared plus y squared is r squared. If you have the x is a r cos theta. And because this one from ds become dA over region R. So the surface area here, the cone from Z1 to Z3, if you project, you will get the donut area because it's bounded from Z1. Z1, you solve it, is actually R equal to 1. Here. And plug in Z1, you solve it, R is 1. Z3, you solve it, R equal to 3. That's why the region R is bounded by R from 1 to 3 and it's full circuit. It involves 4 quadrants. So theta 0 to 2 pi. So Z replaced by the cone equation. And then the region R is circular, which use polar coordinate. dA become R dr theta. Y become R sin theta. X squared plus y squared is r squared. This is a zx squared. From z, you differentiate from the cone equation, which we have a z, you find a del z del x. You get x over square root x squared plus y squared. So zx squared, you square it, you have x squared over x squared plus y squared. So zy is y over square root x squared plus y squared. Square it, you have y squared over x squared plus y squared. Combine these two terms is 1, 1 plus 1, this is sub 2. So sub 2, you factor out. Here r sin theta plus r factor out r. So limit, this is a constant and theta. Because we are going to integrate respect to r first. So r, this is r d theta, so total is r squared, integrate r squared r cubed over 3. Plug in the limit of r. So you have 26 sub 2 over 3. Lastly, integrate sin theta plus 1 respect to theta. Plug in the theta value. Then you get this one, 52 sub 2 pi over 3. This is question 1. Question 2, similar, because it's the same cone equation. Question 2, the same cone equation, but now between z equal to 1 and z equal to 4, and given the density is rho xyz equal to x squared plus z, find the mass of the lamina in the strip of the cone. Copy. Not enough memory. Ayo. I couldn't.
Buat kalau ni
Okay, so it is my RAM problem. I run the MATLAB and the Python. So lacking of memory. Okay. Second question, similar. It's only this is application question. Question 1 is direct question. We don't know what is that. Okay, surface integral represent for what. But this one is application question. Find the mass of the lamina in the strip of cone z equal to set x squared plus y squared between z equal to 1 and z equal to 4. So in this case, if z equal to 4 is similar to question 1, when you z is 4 equal to square root x squared plus y squared. When you square both hand side, x squared plus y squared equal to 4 squared. So r squared equal to 4 squared, r is 4. So in this case, the r is from 1 to 4. Still the donut area bounded by r equal to 1 up to r equal to 4. Only this one involved of the application question. The mass of the lamina is given by the double integral, the surface integral. This is density function, d capital S across the surface S. Because if the rho xyz is 1 or the integrand here 1, so this case means this one, if you have only this, this stands for surface area of the surface S. Surface area, if this is the surface area of surface S here. Okay. So if the integrand is 1, this case surface area represents the surface area of the surface S. So you have the area times the density. That's why you get the mass of the lamina. Okay. Lamina is very thin sheets. Thin consists of area only. That's why it's area times mean the mass. Okay, in this case is a density times the area. Okay, and the density given in this case is x squared z. Okay, so against the z, z you have to replace by set x squared plus y squared, and okay, I think the zx, zy we are obtained in question 1 already, the same because the same cone equation. Okay, so you can refer back, zx is x over set x squared plus y squared, zy is set, okay, x squared plus y squared, and then this one square root zx squared plus zy squared plus 1 dA. When you simplify, you have set 2. Because question 1 and question 2 is similar. This will become region R, x squared, z replaced by the cone equation, exert x squared plus y squared, ds is zx squared plus zy squared plus 1 dA. Okay, and the region R is similar to equation 1, but it's only bounded by the plane z equal to 1 up to z equal to 4. So its R is from 1 to 4. That's why here theta 0 to 2 pi, R 1 to 4, and it's circular. We use a polar coordinate. So x squared will be R squared cos squared theta. Okay, third, okay, this one, square root x squared plus y squared will get R. Because here, square root R squared you have R. Okay, and then the square root x squared plus zx squared plus zy squared plus 1 we have shown in the question 1 is third 2. Okay, dA is R, dr, to theta. In this part, because the same cone equation. Understand? No? Because the same cone equation in equation 1 and 2, same cone equation, zx x over square root x squared plus y squared, zy is y over square root x squared plus y squared. So this part is same, and you solve it, you have third 2 r dr d theta, r dr d theta. So it's only now only the integrand different only. So r squared r power 4. Total is third 2 we can factor out. So total you have r squared, so r cubed r power 4. Okay, integrate r power 4. Okay, you have r power 5 divided by 5. Okay, where over 5 I factor out. Okay, limit of r is from 1 to 4. Okay, and cos squared theta you can change to 1 plus cos 2 theta, or you may use calculator, okay, to integrate it. Cos squared theta is 1 plus cos 2 theta over 2. And you evaluate this one. Okay, 4 power 5. So let's see. 4 power 5 minus 1. Okay, and then this 2, okay, 2, you can factor out and 2. So lastly, integrate 1 plus cos 2 theta theta. So 2 over 10, okay, 4 power 5. So 4 power 5 is 1024. 1024, okay, minus 1. So 1023. Integrate 0 to 2 pi 1 plus cos 2 theta. Okay. So 1023 over 10. So integrate 1 is theta, integrate cos 2 theta is sin 2 theta divided by 2 from 0 to 2 pi. 1, 0, 2, 3 divided by 10. Okay. And then here you have 2 pi. Okay, sin, when you plug in here, sin 4 pi divided by 2. So minus, and plug in theta 0 is sin 0 divided by 2. So it's sin 4 pi 0, sin 0 0. So in left this is only because 0 is 0. So 2 pi and 5 you can cancel it. That's why the answer you have is 1023 multiplied by 5 divided by 5. 5 over 5 32. So this is the answer. So similar to question 1 actually, it's only this is an application question. The mass of lamina in this, okay, if mass of lamina in 2D, okay, then it's only the double integral rho xy. If 2D, if the lamina in 2 dimensions will be the density rho xy A over region R. But this lamina is in the shape of cone. But it means only have the a very thin layer of the shape of cone only. That's why it consists of area only. So the area times density, you have the mass of the lamina in the 3D, 3D space. So this is question 2. Compare question 1 is direct. Is that because it's just directly solved. You don't know what is the meaning of this case space integral. Question 2 is application question where the lamina in 3D space is given by the space integral, okay, of scalar field here. So ds is actually d capital S is replaced by square root zx squared plus zy squared plus 1 to a. Okay, z replaced by the z given is a third x squared plus y squared. Region R is circular, then you use polar coordinate. Okay, for polar coordinate, if you have variable x, change it to r cos theta. X squared will be r squared cos squared theta. X squared plus y squared means in polar coordinate, okay, x is r cos theta, y is r sin theta, x squared plus y squared equal r squared. Okay, so any question, okay, for this is 2 questions, okay, for you to revise the space integral of scalar field. Okay, if no, we move to look at the the space integral of vector field. Okay, let the sigma be the surface of the plane z equal to. Okay, sometimes they use sigma as a surface, or sometimes the s is just a notation only. The surface, some books they use sigma, some books they use an s, so it's only notations. So let the sigma be the surface of the plane z equal to xy, bounded by x from 0 to 1, y from 0 to 2. Okay, and the vector field given fxyz equal to z squared j minus x cubed y power 4 k across the sigma. Assume that the n is a unit normal vector, okay, oriented upward. Okay, if you download the tutorial question, the upward I already changed it because out can be up or down, so I changed it to upward, and then evaluate, okay, the plot integral or the surface integral of vector field, and the answer also in, okay, if you download, okay, this is the latest answer. Evaluate the plot integral, which is given by double integral f dot n ds. S, capital S is a surface, okay, one unit of the surface area across a sigma or sometimes across a S, just the notation. Okay, we want to evaluate this one. So, okay, the unit normal vector is oriented upward. This is sigma or S. It doesn't matter, it's only the notation. Okay, F dot n. For the unit normal vector which is oriented upward, okay, will be, this is a vector, negative component I, the normal vector component I will be negative del z del x. Component j is negative del z del y. Component k positive, that's why oriented upward. Okay, numerator, this is normal vector. If you want unit normal vector, have to divide by magnitude of the normal vector. So magnitude of a vector, have the square root, and then you square each component. Okay, this I can simplify as zx squared. Okay, component j here, negative del z del y, you square it, will be zy squared plus component k, you square it. So this part is actually the unit normal vector. Or this term is a unit normal vector. Okay, ds is here, zx squared plus zy squared plus 1 dA over region R. So S will become R. Okay, and then square root here, cancel. Okay, that's why we are just left f dot with the normal vector. It become double integral over region R. Okay, f. What's the f? Now, what's the f given? If you see what's the f there?
Z square J minus X cube Y.
Z squared j,
Yeah.
and then component k?
X cube Y power of 4.
X cubed y power 4. Not enough memory. So component I 0, component j is z squared, component k x cubed y power 4 dot with this one. You need to dot with negative del z del x I, negative del z del y j plus positive k. Points k you need from the z. what's the z equation given? Z equal to xy, is it?
Yeah, XY.
Z equal to xy.
Yeah.
Okay. This is z equal to xy. So zx will be y. Zy will be x. Okay, and then if we want negative zx, so means negative y. Negative zy is negative x. That's why here we want negative zx. So this is negative y, this is negative x, 1. E8. And you find the dot product first. You simplify the dot product, later on do the double integral. Okay, component I 0 times negative y, so is 0. Component j, okay, component j is we have negative x z squared, and then okay, we will do this way. 0 times negative y 0, okay, and then here z squared times negative x, we have negative x z squared. Okay, and you give plug with here x cubed y power 4 multiplied with 1, so it plus x cubed y power 4, so d8. Okay, so I hope you, okay, the term z squared you replace back by z is what? Okay, the surface z is x times y. Okay, simplify first. So in negative x, okay, z, so x y squared plus x cubed y power 4 d8. Simplify first before we integrate using double integral. So it's negative x squared x, so x cubed y squared plus x cubed y power 4 d8. Okay, and then the region R, okay, just now, okay, x from 0 to 1, y from 0 to 2. So you put out, okay, say x 0 to 1, y 0 to 2. Negative x cubed y squared plus x cubed y power 4 dy dx. You notice a mistake here? 0 negative for this positive x cubed x cubed. We factor out the x cubed here. Okay, y squared plus y power 4 x cubed, and then dy dx. Okay, factor out x cubed, okay, because I would like to integrate respect to y first, so x cubed is constant. Okay, when I factor out x cubed, okay, now I have negative y squared plus y power 4 in bracket x cubed, okay, dy dx. Okay, now integrate respect to y. Negative y cubed over 3 plus y power 5 over 5 till from 0 to 2. The outside is x cubed dx. So we plug in the value, so negative 8 over 3 plus 2 power 5 is 32 over 5. Okay, when plug in 0, everything 0. So x cubed dx. Then so it simplified negative 8 over 3 plus 32 divided by 5. We have 56 over 15. Lastly, integrate 0 to 1 x cubed dx. Okay, the last one, you may use your calculator, or this part also, if the integrate respect to y because it's the limit is constant, you can also this part if you want, let's say here, this part. If you want to use calculator, also can, because integrate respect to y for this is constant limit, then you can use calculator. Okay, and then if you evaluate manually, so this is 56 over 15, integrate x cubed x power 4 over 4 from 0 to 1. So simplify this one. 56 and 4, you simplify it. So 40 over 15. So it's also good. Over 5. Check again here. Negative 34 over 5. Okay. The plug integral f dot the unit normal vector is which is oriented upward. We have negative del z del x, negative del z del y. Okay, this I j k divided by the square root zx squared plus zy squared plus 1. ds is the square root zx squared plus zy squared plus 1 a. Okay, we simplify it. Okay, f is z squared k component j. Here, this part is minus under. Okay, component k is negative. Negative x cubed y power 4. Sorry. So this one is negative. So component I 0 times negative y gets 0. Component j z squared times negative x. So negative x z squared. Component k negative x cubed y power 4. So this one, this is negative This is negative. This is negative. Negative. Okay, can you make the corrections? Because my here is hanging. If you make the correction, show that you get the answer as given there. Negative, negative, this is negative. So negative y squared y cubed over 3 negative y power 5 over 5 0 to 2. Here. This value is negative. Negative. So can you get the answer or not? It's hanging, cannot do anything. On. And then divide by 4. Negative 54 over 15. What is the answer just now that I showed? I cannot move at all. The word is not responding. Okay, if you make the correction, you check just now what are the answers that I showed to you. Because I cannot move at all. Not responding. And then you have the question 2, right? Okay. Question 2, you can try to do first. This one, negative 8 divide 3 minus 32 divide 5. This is negative 136 divide 15. And then integrate x cubed, you got x power 4 over 4 from 0 to 1. So divide by 4. Get negative 34 over 15. At all. Okay, what is answer that you obtain?
Same way that 54 over negative 2.
Negative 34 over 15.
Yes.
Okay, just now, did you see what is the answer that I display on top? So, I not move at all.
I remember the answer is negative 3 over 50. Over 5.
Over 5.
Yang when I download tu saya quickly open dalam bentuk ni.
The download one, the answer is wrong. Because I just make the correction last night. After I upload it, I just make the answer. Okay, the downloaded one, the answer is wrong. And I get slowly this one. Okay, and you can try to do question 2 first while waiting here. Not enough memory. Submit here. Now is negative 34 over 15. Yes.
Number 2 question
Yeah.
tu dia punya tu memang aku ya.
Huh?
Kan betul tukar yang dia kata yang upload kan dalam tu
Yeah. Because outward it can be up or down. So I change it to upward.
question tu memang upload.
Up
Okay,
also.
tak pula.
Up also. Upward also.
Tak pula.
Okay, here maybe I typo it. Not want to check it. Okay, the answer here later because I couldn't open any document. Okay, question 2 similar. Can you please try it? Here I give you negative 34 over 5. You can check, but I couldn't open any document. You try to do question 2 first. Question 2 similar. In the same process, only the vector f change slightly. This one the answer is wrong. I think the typo mistake. Negative 34 over 15. Negative 34 over 15. And then now the question 2 similar process, but my computer hanging. So So the answer negative 34/15. This is for because here is 136/15. 136/15. Here you have 1/4. So the answer is negative 34/15. Okay, question 2. So we find z is x squared y. So zx will be 2x, zy will be 2xy. Zx is 2xy, zy is x squared. So negative zx, we have negative 2xy, negative zy will be negative x squared. Okay, and from just now, from question 1, you know that the plug integral f dot n d capital S cause the space S. If the unit normal vector I change to upward, because out can be up or down. So this one, when we simplify, we'll get the actually f dot with the unit dot with normal vector, which is negative zx, negative zy, and positive k cross dA over region R. So we go back question 1 just now. The unit normal vector, this one is normal vector divide by, you have the square root zx squared plus zy squared plus 1. ds also have that same square root, cancel each other. That's why when simplify, we get the double integral f dot with negative zx, negative zyj plus k dA. So now we plug in with the f value. With f, we have also component k, j is z squared. Z squared negative is negative x squared y. Negative zx will be negative 2xy. Negative zy is negative x squared. This is 1k dA. Solving the dot product first. Cross region R. So we have 0, component 0 times negative 2xy have 0. So component j, z, we have a negative x squared, z squared. Component k, we have the negative x squared y times 1 dA. Z squared times negative x squared, so negative x squared z squared. Component k is a negative x squared y times 1, so you get negative x squared y dA. And then you have to replace back z is x squared y, where the z is actually the x squared y. Therefore, negative x squared z is actually the x squared y, and then squared. So negative x squared y outside left dA. Simplify first before we integrate. Let's integrate using double integral. So total x power 4, x power 6. So negative x power 6 y squared, negative x squared y dA. Okay, and then now I think also same thing, x from 0 to 1, y from 0 to 2. 0 to 1, y from 0 to 2. So integrate respect to y first, where the x is constant. Okay, the dA becomes dy dx. So now integrate respect to y, where the x is constant. The y cubed over 3 minus x squared y squared over 2. Okay, y from 0 to 2, then x. So negative 8 over 3 x power 6 minus, okay, this is 2 squared 4 divided by 2, so 2 x squared dx. Lastly, integrate respect to x. So negative 8 over 3, so 5 x power 7 over 7 minus 2 over 3 x cubed, x from 0 to 1. Negative 8 over 3, 1 over 7 minus 2 over 3. 8 divided over 7. Answer negative 22 over 21. Is it correct? Okay? Negative 22 over 21. Okay, this is a second question. Okay, similar to first questions here. It's only the plane cake now is z equal to x squared y. So you find zx, which is 2xy, zy is x squared. Okay, the zx, zy is needed okay, from here. Plug in here, negative zx, negative zy. Then you do the dot product, okay, do the dot product. Lastly, evaluate, become the problem of okay, your double integral. After you plug in the z is actually the x squared y. Okay, so this question, okay, and any question or not? Okay, question 2 here.
Okay.
The rest having covered, and let's move back to tutorial 10. Tutorial 10, any okay, will cover okay, the test 2 will cover until the green theorems. Because okay, this tutorial left Gauss and Stokes that will be covered okay, next week. So we can look back tutorial 10. If you have any question on the tutorial 10 there. Okay, tutorial 10, the answer is okay, uploaded already, the answer. But do you have any question that you want to ask? Okay, correct. Any question that you want to ask or not?